So in this video, we're going to take a look at how you can convert any object in your scene to save and restore some arbitrary data using a generic save data class that shipped in the first-person exploration kit update. So in this case, we're going to take a look at the demo cabinet that shipped in the previous version. And in order to make that savable, we'll need to make some minor modifications to the code. So just to demonstrate what I'm talking about, if I open the cabinet here and I save the game, when I restore the game, the behavior I want to see is that the cabinet is open. That makes sense. So what happens actually right now is when I restore the game, the cabinet's closed because that's its default state. Nothing was saved, nothing was loaded, so that's a problem. So we're going to take a look at how we can change this script to behave in the way that we want and restore the open or closed state when the game is loaded. So the first thing we need to do is open this script, demo cabinet script. It's currently a mono behavior. What we need to do is change this to be a generic savable game object, which is a new class that is also derived from mono behavior. So all your mono behavior stuff can stay there, start, update, awake, all that stuff. So no changes needed there. But you'll see right away there's this red underline under your class name. So it's complaining that this script doesn't implement inherited abstract member, restore save game data, and get save game data. So if you click on the little light bulb here, and click on Implement Abstract Class, what that will do is put two new functions at the bottom of your class that you'll need to plug in some logic so that the data inside of this class can be saved and restored by the save load manager, which will happen automatically when the game is saved and loaded. So the first thing we're going to do is we know we have to return this class called FP generic object save data. So that's just a little container that has some values in it, just a generic set of values, an int, a float, a bool, and then a name. So if we return a new one of those, you'll see in the constructor we have an object name, object int, float, and bool. So in this case, we really only care about the cabinet open condition, so whether that was true or false. So we'll ignore the int and the float, we'll just give those zeros. But one thing that is important is that we put our own object name in there because that's the thing that the load game logic will match against to restore this data. So if we put gameObject.name, we'll just do 0f, and then we want our cabinet open variable. So what that will do is return a little data set that captures the state of our object here. So our demo cabinet will say, hey, save game, I was open or closed, depending on my state. And then that'll get written to the save game and then restored in the restore save game data function. So to restore that data, we need to assign the value to our cabinet open. So when we get that data back from the game loading logic, we want to grab our saved bool because that's the thing that we saved up here. The object bool there, cabinet open, that will be what was saved. So when we restore it, we want to grab the saved bool value and assign that back to our internal state. So the next thing we need to do is check what was that value and then handle that. So if the cabinet was open, we just call our open cabinet function. So if we go back over to Unity, we try that open save load test again. I'll go over here and open the cabinet, save my game, and when I load my game, we expect that the cabinet will open or be opened again. So if we take a look at that, the cabinet's now open, but we saw the animation play, which isn't ideal, because if it was a quick save or quick load, we don't want the player to see the cabinet open when they load their game. That doesn't really make sense from a gameplay perspective. So we're going to take a look at how we can set the animation state to be exactly where we want it to be when we load the game, and we'll put that inside of our restore save game data function. So if we take a look at the animator for our cabinet, there's a state here called cabinet open, which has been added in this update for this specific purpose. But basically what happens is that once the cabinet is finished opening, it transitions to this cabinet open, which is a clip that basically just keeps the doors in their open position. And then when the player wants to close it, they can close it if the close cabinet trigger is fired per the existing logic. So if we look at the logic we had before, the open and close have been modified a little bit to reset some triggers and set this bool for forcing the cabinet open to be false. And we've changed our restore logic to instead just say open cabinet, which plays the animation from close to open. What we do is we update our interaction strings again to say close cabinet because we want the cabinet to say close me when its doors are open. So if our cabinet was open, we put the doors back at the open position, and then the interaction string says close cabinet, which makes sense. And then we're setting this bool called force cabinet open, which puts us into this cabinet open state So if we run the scene again after we've made those changes to our restore save game data function, and we try the same test again. So walk over to the cabinet, open it, hit save. When we restore the game, the cabinet is just open. There's no sound, there's no animation, anything. So the modifications we made were pretty basic. We just changed from a mono behavior to this new generic savable game object. And then we put in a little bit of custom logic here to handle saving out the data we wanted to save, in this case, just our cabinet open flag. And then when we restore, we only really have to care about if the cabinet was open when the game was saved. And if it is, then we just kind of reset our animation triggers and our interaction strings, and then everything works as we expect it to.